Download this code from codegive.com, link in the description below. OK, let's dive into using Binary Ninja for bug hunting, heavily influenced by the techniques and insights of Jordan Wiens, a renowned security researcher. This tutorial will provide a comprehensive guide, incorporating code examples, practical techniques, and considerations for various types of vulnerabilities. Disclaimer *: this is a large, detailed guide. It's going to cover a lot of ground. You'll need to have Binary Ninja installed and licensed to fully utilize it. You'll also benefit from having some familiarity with assembly language, especially x86/x64 or ARM, reverse engineering concepts, and common vulnerability types. Setting the stage, why Binary Ninja for bug hunting? Binary Ninja is a powerful reverse engineering and binary analysis platform developed by Vector35. It's favored by many security researchers due to its lifting to intermediate representation. Binary Ninja's primary strength lies in its ability to lift assembly code into a more abstract, architecture-neutral intermediate representation, IR. This simplifies analysis, especially when dealing with different architectures or obfuscated code. It's easier to reason about data flow, control flow, and logical operations at the IR level. Python API Binary Ninja has a robust Python API that allows you to automate analysis, write custom plugins, and extend its capabilities. This is crucial for bug hunting, as it enables you to perform tasks like identifying specific code patterns, tracking data flow, and detecting potential vulnerabilities. Graph views excellent graphical representations of function control flow graphs, CFGs, and data flow graphs, DFGs, are essential for understanding the behavior of a program and spotting potential issues. Symbolic execution, with a plugin. While not built in, plugins like Falcon can integrate symbolic execution engines, which are useful for exploring program paths and generating test cases. Headless mode Binary Ninja can be run in headless mode, without a GUI, allowing you to perform automated analysis on a server or in a CI/CD pipeline. 2. Key concepts and techniques Jordan Wiens emphasizes. Jordan Wiens, known for his work on exploitation techniques, often uses a combination of approaches. Understanding the program's purpose Before diving into assembly, try to understand what the program is supposed to do. This can be done by running it, reading documentation, if available, and using strings analysis. Focusing on input handling vulnerabilities often arise in how a program handles external input. This includes command line arguments, environment variables, files, network data, and user interfaces. Look for places where the program reads, parses, or processes input. Data flow analysis Tracking the flow of data from input to output is critical. Pay attention to data conversions, string operations, memory allocations, and any operations that could lead to an error if the input is malformed. Control flow analysis Understand how the program's execution path changes based on input. Look for branches, loops, and function calls that depend on user-controlled data. Vulnerability patterns Learn to recognize common vulnerability patterns, such as buffer overflows, format string bugs, integer overflows, use after free errors, and race conditions. Automated analysis with scripts Leverage Binary Ninja's Python API to automate the process of searching for these patterns, highlighting potential areas of concern. Hybrid analysis combines static analysis, analyzing the code without running it, with dynamic analysis, running the program with specific inputs, to gain a more complete understanding of its behavior. 3. A practical example, finding a buffer overflow. Let's illustrate a common vulnerability, a buffer overflow, and how Binary Ninja can help us find it. A. The vulnerable program, in C. Compile this program, example gcc overflow.c no stack protector. The no-pi and no stack protector options are used for demonstration purposes, making the vulnerability easier to exploit. In a real-world scenario, these protections would be enabled. B. Loading the program in Binary Ninja *. 1. Open Binary Ninja. 2. Load the compiled executable, overflow. Binary Ninja will automatically analyze the binary, disassemble the code, and identify functions. C. Identifying potential vulnerabilities, manual analysis. 1. Strings analysis * in the Binary Ninja interface, go to view-strings. Look for strings related to input or output, such as usage or input. This will help guide you to relevant parts of the code. 2. Main function * find the main function in the function list, usually on the left pane. 3. Analyzing the code * inspect the disassembled code within the main function. You'll see something similar to this, simplified x86-64. 4. Spotting the vulnerability * notice the strcpy function call. strcpy is a classic source of buffer overflows because it doesn't perform bounds checking. It simply copies bytes from the source to the destination until it encounters a null terminator. If the source string is longer than the destination buffer, it will write beyond the buffer's boundaries, potentially overwriting important data on the stack, like the return address. D. Automated analysis with a Binary Ninja script, Python. Now, let's create a Python script to automatically identify potential strcpy vulnerabilities. This script will iterate through all functions in the binary and look for calls to strcpy. How to run the script *. 1. Save the script as find_strcpy.py. 2. In Binary Ninja, go to Tools-Run Script. 3. Select the find_strcpy.py file. 4. Pass the binary name as a command line argument to the script, by selecting the Arguments tab in the script dialog, and adding the name of the binary as an argument to the script. 5. The script will output the address of any strcpy calls it finds to the Binary Ninja log window, view-show log. Explanation of the script *. Binary Ninja import * imports the necessary Binary Ninja modules. *find_strcpy_calls, BV, function *. Takes a binary view object, BV, as input, representing the loaded binary. Finds strcpy symbol *. Attempts to get the address of the strcpy function using bv get _symbol _by _name, strcpy. This works if strcpy is imported as a symbol in the binary, example from the standard C library. If the binary is stripped or doesn't import strcpy directly, you might need to manually locate its address. Iterates through functions * loops through each function in the binary using BV functions. Iterates through blocks * within each function, it iterates through the basic blocks, using function.low_level_il. The low-level intermediate language, LLIL, is a more abstract representation of the assembly code, making it easier to analyze. Iterates through instructions * within each block, it iterates through each instruction using block. Checks for LLIL_call checks if the instruction is a function call, instruction.operation == LLIL_call. Identifies strcpy calls * if it's a function call, it checks if the CALI, the function being called, is strcpy. It extracts the address of the CALI and compares it to the address of strcpy we found earlier. Asterisk logs the result asterisk if a strcpy call is found, it prints a message to the binary ninja log window, including the function name and the address of the strcpy call. Asterisk main execution block asterisk. Asterisk gets the binary view of the file using binary view.get underscore view underscore of underscore file, argv1. It assumes the first command line argument, argv1, is the path to the binary file. Asterisk calls the find underscore strcpy underscore calls function to perform the analysis. Expanding the script, advanced analysis. The above script is a basic example. We can expand it to perform more sophisticated analysis, such as 1. Tracking data flow to strcpy asterisk. We can use Binary Ninja's data flow analysis features to trace where the arguments to strcpy come from. This can help us determine if the size of the source string, the second argument to strcpy, is controlled by user input. This expanded script attempts to trace the source of the second argument to strcpy back to its origin, showing the instructions that define the value being passed to strcpy. This will give insight into whether the input is user-controlled or a fixed value. 2. Checking buffer sizes, static analysis. If we can determine the size of the destination buffer and the potential size of the source string, we can statically assess whether a buffer overflow is likely. This can involve examining the memory allocation instructions or the sizes declared in the code. This is a more challenging task, as it requires understanding the program's memory layout. 3. Symbolic execution. With the Falcon plugin, you can symbolically execute the code path leading to the strcpy call. This allows you to explore different input values and determine if any of them can cause the buffer to overflow. Dynamic analysis, verification and exploitation. Static analysis can only go so far. To confirm the vulnerability and develop an exploit, you'll need to perform dynamic analysis. 1. Fuzzing asterisk. Use a fuzzer, like AFL, libfuzzer, or Binary Ninja's plugin, to automatically generate a large number of inputs and run the program with each input. The fuzzer will monitor the program for crashes or other anomalies that indicate a vulnerability. Send longer strings to the overflow program. This will likely cause a segmentation fault, crash, because you're writing beyond the bounds of the buffer. 2. Debugging asterisk. Use a debugger, like GDB or Binary Ninja's built-in debugger, to step through the code execution and observe what happens when you provide an input that triggers the buffer overflow. You can set breakpoints at the strcpy call and examine the contents of the buffer and the stack. 3. Exploitation asterisk. The goal of exploitation is to control the program's execution flow. In the case of a buffer overflow on the stack, you can overwrite the return address with the address of your shell code, malicious code. This is a more advanced topic, but it involves careful crafting of the input to place your shell code and the desired return address at the correct locations in memory. 4. Other vulnerability types and Binary Ninja techniques asterisk asterisk. Let's briefly discuss other common vulnerability types and how Binary Ninja can be used to find them. Asterisk. Format string bugs asterisk. Asterisk. Vulnerability asterisk occur when a program uses user-controlled input as part of a format string in functions like printf, sprintf, etc. This allows attackers to read or write arbitrary memory locations. Asterisk. Binary Ninja asterisk. Search for calls to format string functions, printf, fprintf, sprintf, etc. Track the source of the format string argument. If the format string comes directly from user input, it's a potential vulnerability. Asterisk scripting asterisk write a script that identifies format string calls and checks if the format string argument is derived from user input. Asterisk integer overflows asterisk. Asterisk vulnerability asterisk occur when an arithmetic operation results in a value that exceeds the maximum or minimum value of the data type. This can lead to unexpected behavior, such as buffer overflows or incorrect calculations. Asterisk binary ninja asterisk analyze arithmetic operations, addition, subtraction, multiplication, division, that involve user-controlled input. Look for cases where the result of the operation is used to determine the size of a buffer or other critical parameters. Asterisk scripting asterisk write a script that identifies arithmetic operations and checks if the operands are user-controlled and if the result is used in a potentially dangerous way. Asterisk use after free, UAF. Asterisk vulnerability asterisk occurs when a program attempts to access memory that has already been freed. This can lead to crashes, data corruption, or arbitrary code execution. Asterisk binary ninja asterisk analyze memory allocation and deal location patterns, example calls to malloc, free, new, delete. Track the lifetime of pointers to identify potential UAF vulnerabilities. Asterisk scripting asterisk this is complex. Write scripts to analyze the usages of pointers after a free call to see if they might be used. Asterisk heap overflow asterisk. Asterisk vulnerability asterisk writing past the boundary of a dynamically allocated buffer in the heap. Often exploitable, especially with modern heap allocators. Asterisk binary ninja asterisk analyze calls to malloc and related functions, and track sizes and allocations. Inspect memory copies or other writes to see if they can exceed the allocated size. Asterisk scripting asterisk write scripts to detect if a memory copy can write more bytes than the allocated buffer. V. Jordan Wiens principles applied asterisk. Asterisk focus on input handling asterisk for all the vulnerability types above. The key is to focus on how the program handles input and how that input is used in calculations, memory operations, or control flow. Asterisk data flow and control flow analysis asterisk track the flow of data from input sources to potentially vulnerable functions. Understand how the program's execution path is influenced by user input. Asterisk vulnerability patterns asterisk learn to recognize the telltale signs of each vulnerability type. Asterisk automate with scripts asterisk leverage binary ninja's Python API to automate the process of searching for these patterns. Automate checks for potential sources of vulnerabilities, example strcpy, printf, arithmetic operations involving user input. Asterisk hybrid analysis asterisk combine static analysis, using binary ninja, with dynamic analysis, fuzzing, debugging, to gain a more complete understanding of the program's behavior. 6. Conclusion. Bug hunting with binary ninja is a powerful and effective approach. By combining its powerful analysis capabilities with a solid understanding of vulnerability patterns and a focus on input handling, you can significantly increase your chances of finding security vulnerabilities in binary code. Remember to leverage the Python API to automate your analysis and to combine static and dynamic analysis techniques for the best results. Study the techniques of security researchers like Jordan Wiens to improve your overall reverse engineering and bug hunting skills. This guide provides a solid foundation, but continuous practice and learning are essential for becoming a skilled bug hunter.